Hello, my name is Naufal Amshar bin Azhar. We are from Group E and we will be presenting about the open-ended experiment. So for this experiment, balancing of rotating machinery is important in order to reduce the vibration and the mechanical stress. Static balancing happens when the resultant gravitational moment is zero on the shaft and it remains stationary. For dynamic balancing, it is required to eliminate both the resultant centrifugal force and the couple moments along the shaft. And however, a system, although the system is statically balanced, it may still be experiencing vibration when it is rotating. And this experiment investigates both static and dynamic balancing to demonstrate their importance in achieving stable operation of rotating systems. Moving on to the objectives of the experiment, first is to determine the static balancing condition of a shaft with multiple masses. Next, to investigate the dynamic balancing behavior of a rotating shaft. And finally, to compare the effectiveness and limitations of static and dynamic balancing in minimizing vibration.
Hello, good day. I'm Kelvin John Ha, metric ID 223672. So our experimental plan follows a two-phase approach. First, we determine the blocks by measuring their MR values using steel balls by putting it in a bucket till it tilts 90 degree. Step 2, to solve the static balance, we fix the mass 1 and mass 4 at specific angles, allowing us to calculate the exact angles for the remaining two. And step 3, for dynamic balance, we use mass 1 as our reference plane and fix mass 2 at specific distance to provide a baseline, which allow us to mathematically determine the exact spacing needed for the rest. Thank you.
Hi, my name is Aidil Hadif Majura Effendi and my metric number is 225307, and today I'm going to discuss about the procedure of static balance experiment. So first, the perspex dome and the shaft drive belt were first removed from the apparatus. The extension pulley was unclipped and fitted onto the pulley end of the motor-driven shaft. The out of balance moment (MR) of each block was measured separately by attaching a weight bucket and gradually adding steel balls until the block rotated by 90 degrees. The position of the three blocks was specified by the demonstrator and mounted on the shaft. Accordingly, the angular position of the fourth block required to achieve static balance was determined using either the calculation method or the moment polygon graphical method. The fourth block was then mounted on the shaft based on the calculated or drawn position. And lastly, the static balance was confirmed by checking whether the shaft remained stationary at all angular positions. So next is the procedure for dynamic balance experiment. The perspective dome and the shaft drive belt were removed from the apparatus. All the blocks are positioned using the calculation shown in the step 4 calculation. The perspective dome was put on and a coin was put onto the perspective dome. The motor to rotate the shaft was switched on. And lastly, dynamic balance was confirmed by checking whether the coil on top of the perspective dome remained while the shaft was rotating with all the blocks attached.
Hello, I'm Howard, module number 218646. I'm going to talk about result and discussion. In our experiment, we apply the concept of statics and dynamic balancing from our lecture to our open-ended lab. In the first part, statics balancing, we use small ball as shown in the figure. We place them on the mast connected to the shaft to create a momentum to make the mass remain stationary at 90-degree angle. Why? Because in this position, the gravity creates maximum torque. We can simply know the MR value by counting the number of balls. So, it is worth to mention friction in this case is negligible as it does not affect our measurement too much. Next, in the second part of the experiment, dynamic balancing, the goal was to make the center of gravity of the shaft as close to the center of rotation. We use MR value obtained from the static balancing, calculate the precise position of four different masses connected to the shaft, as shown in the figures on the right. After adjusting masses, the shaft rotated at minimal rhythm, smooth enough that we could place a coin on it without falling, confirming our understanding of mass balancing is correct. Lastly, our experiment effectively demonstrates the principle of statics and dynamic balancing. However, we encounter issue and there is limitation about experiment. In the laboratory, the equipment provided lacked of angular measurement tool, which made the positioning of the mass depending on the human estimation. So, additional of the protractor can further reduce human factor, making operation of the shaft even smoother.
From the experiment, static balancing was achieved by determining the MR of each mass, and while dynamic balancing was completed using the reference plane method. Also, the final mass arrangement resulted in smooth shaft rotation, and the bearing on top of the dome didn't move that much and didn't fall, which means that both force and moment equilibrium were successfully attained. Overall, the experiment demonstrated the importance of dynamic balancing beyond static balance and strengthened our understanding of balancing in real rotating machinery. Thank you very much.